Hello there and welcome to question 7 from revision sheet 1. So question 7 is a show that proof in the series chapter. So I'm looking to use my standard formulas to show that the summation of this can be rewritten as an expression summing from 1 to n. So for the first part, I think I will start with expanding these brackets. So 2r cubed add r. Okay, so now what I'm going to do next is split up this summation here into two separate summations, and I can also pull out a factor of 2 from this summation as well. So I can rewrite this as 2 times the summation of r cubed add the summation of r. Now here's where I need to recall those memorized formulas for r cubed and for the sum of r. And the formulas are, for the sum of r cubed, n squared over 4 times n plus 1 squared. Notice how I still have to times at the front by a times by 2. And then the formula for the summation of r is n over 2 bracket n plus 1. Let's just simplify up these fractions. So 2 over 4 will just leave me with a fraction of 2 on the bottom. And the second part of this term is already simplified. So the next thing I would do if I had to is create common denominators by writing up equivalent fractions in these two terms here. But in this case here, they're both 2. That helps me a lot. So now I can start the factorizing step. First of all, I'll pull out a factor of 2 from both of these terms and look for what algebraic terms are in common to both of these terms. I can see I have an n from the n squared and the n, and I also have an n plus 1 from here and from here. So I'll pull out n plus 1 as well. When you're doing these sorts of questions, try and pull out as much as you can to make the final bit of algebra inside this squared bracket as easy as you can. Let's look at what I need inside this bracket here. So I've already got n over 2 and n plus 1 factorised, so I need whatever's left over in each of these terms. In the first term it's an n, because I've only got an n here, so I need to make an n squared from above, and I need another n plus 1 to make the n plus 1 squared. For the second part of the term, I already have the n, I already have the fraction of 2, and I already have the n plus 1. So all I need for that bit there is just plus 1. Let's now rewrite this out by expanding the squared bracket. So this is going to be n times n, which is n squared, add n times 1, which is n, and then add the 1 on that I have at the end. And that's just what I wanted. N squared plus n plus 1 inside that final bracket. So little square showing that I've proved it. Great. Moving on to part B. Have a go at part B even if you haven't fully completed part A in these sorts of questions, because it's a show that and you've already got the formula that you need to use. The difficult part of this question, however, is we're starting at 26 in our summation for r, and starting at r equals 26 and going up to 58, where our formula only starts at 1 and goes up to a value n. So we can vary this number at the top, but we can only use this formula if we start at a bottom number of n. So what we have to do here is, if we are starting at 26 of our expression here, 2r squared plus 1, is split up this summation from 58, but we'll include some more terms down below. So we'll include all the terms down to 1, because that's the only way that I can use my formula. R bracket r squared plus 1. And then what I'm going to do is I'm going to subtract all the numbers that are less than 20, all the r value numbers that are less than 26. I want to include 26, so I'm going to subtract all of those r values from 25 down to 1. of our expression r bracket 2r squared plus 1. So what do I get here? I need to substitute 58 into the formula here in 3 parts, here, here, and here and here. So for my formula for the first bit, it's going to be 58 over 2, bracket 58 plus 1, bracket 58 squared plus 58 plus 1, and then subtract 25 substituted into this formula. So 25 over 2, bracket 25 plus 1, bracket 25 squared, add 25, add 1. Write that into your calculator and you should get an answer of 564,564,5178. That's your answer to part B. Let's just check this on our calculator and I'll show you how to use the calculator mode for this sort of question. So, the calculator mode, if you look at the top right hand side of your calculator, has a yellow icon that is a summation symbol. Press Shift and then the X button to recall this summation function, and then you can substitute in straight away this summation from 26 up to 58 of our expression here. So what we have to do here is, using the up and down buttons, get the cursor in the right point such that you can substitute in the numbers 26 and 58 here. The expression here that's written next can't be written in R, unfortunately. You have to use this X button, the same button that you use for the summation series function. So type in X bracket 2x squared plus 1, close the bracket, and you should get exactly the same answer doing it this way as you did using the formula way. If you do get a different answer, go back to your working or check that you've done it correct on your calculator. They should always equal the same thing. 6 marks in total.